Good evening, everyone. Today's topic for chemistry is coordination compound. We are starting with introduction. Coordination compounds are those compounds which are having coordination bond in it. Now, what is the meaning of coordination bond? I am giving you an example. The type of bond formed by sharing of lone pair of electron is known as coordination bond. Okay, so here the compound which is written first in bracket is known as central metal atom, and the element which is written first inside the bracket is known as central metal element or central metal ion, and other elements from that bracket are known as ligands. So the approach of ligands towards central metal occurs through sharing of lone pair of electron, and the type of bond which is formed by sharing of lone pair of electron is known as coordination bond. Okay. Coming back to the topic, I'm giving you a little introduction. अभी थोड़ा सा जनरल आइडिया लेते हैं कि कोऑर्डिनेशन कंपाउंड में चीजें होती क्या क्या है. Everything inside the square bracket is known as coordination entity. Okay, the first element inside the square bracket is known as central metal atom, and the square bracket itself is known as coordination sphere. The elements or compounds which are attached through central atoms are called as ligands. Okay, it may be anionic or neutral. The point to remember is that ligands can never be cationic. They will be either anionic or neutral, which means they will be a charge either negative or no charge. This thing is known as counter ion. Counter ion means the type of compound, it may be element or compound which came to counter the oxidation number of central atom. How? Let us see here. K4 Fe Cl6. This was our compound. We know the charge of one Cn is -1, and we are having 6 cyanide. I am expecting that you might be knowing how to calculate oxidation number. To calculate the oxidation number of central atom, let us suppose it as X. And now see the role of counter ion. It is used to balance the charge of central atom. We know the charge of 1 potassium is +1, and we are having here 4 potassium. Overall charge is negative, nothing, so we will assign here 0. X plus 4 minus 6 is equal to 0, so we got X is equal to plus of 2. So oxidation number of central atom will be +2. Clear? तो अपन अभी क्या क्या सीखे? अपन सीखे अभी कि कंपाउंड को क्या क्या बोला जाता है, क्या क्या इसमें लिखा गया है, कौन सेंट्रल एटम है, कौन लिगेंड है, कौन कोऑर्डिनेशन स्फीयर है, कौन सा कॉन्फिगरेशन एंटाइटी. ये आपको चीजें पता होनी चाहिए थी. बढ़ते हैं नेक्स्ट पेज पे. पेज टर्न कर रहा हूँ. Now, in this chapter, we should be knowing few topics, starting from ligands. Ligands can be of following two classification. So ligands can be of following types. First is homo unidentate, then didentate, then polydentate. One more classification is left, ambidentate. Clear? Now we'll learn about what are these ligands. The type of ligand which is having only one attacking site. Example, Cl, comma, NH3. Okay, these are the examples of unidentate ligands. Now didentate, the type of ligands which are having two attaching sites. Example, NH2, CH2, CH2, NH2. We know that coordination bond is formed by sharing a lone pair of electron, and the type of bond formed here also from amine. No, it is ethane 1,2-diamine. So the type of bond here will be formed by sharing of lone pair of electron, and they both of the terminal amines are capable of donating electrons. Okay. So it is known as didentate ligand. Polydentate ligand having more than two attaching sites. Example, KDDA, coming to ambidentate ligand, it is a type of ligand having more than one attaching site in same compounds. Okay, example, cyanide. It can also get attached as NC, and the name will be changed to isocyanide. So these are the type of ligands. Now, types of complexes. There are basically two types of complexes: homolytic and heterolytic. Homolytic and heterolytic. The main classification between homolytic and heterolytic complexes is homolytic complexes are having same type of ligands, or you can say that only one ligand, one type of ligand. We'll be sharing an example. Same K4 Fe CN6. You are observing the ligand used here is cyanide, and only cyanide is used in forming this kind of complex, whereas in hydroelectric complex they are having different types of ligands in same compound. Example. Both are anionic ligands having similar charge. Any term missing? No, fine. Next we'll see coordination polyhedra. Coordination polyhedra means the three-dimensional arrangement of compounds is known as coordination polyhedra. And overall charge in this compound will be 2 plus, which we have already calculated earlier. See here, one more important thing, point to be noted, that central atoms are known as Lewis acid, whereas ligands are called as Lewis base. Now, the main thing before representing them as a Lewis acid or Lewis base is, we already know, or either you know or not, I'm telling you, Lewis is a scientist who gave concept about acids and base. According to Lewis acids are compounds which can accept pair of electrons, and Lewis base are compounds which are capable of donating pair of electrons. Okay, so Lewis, the concept of Lewis is the compounds which are capable of donating electrons are known as Lewis base, and the compounds which can accept electron are known as Lewis acids. Fine. Now we know the type of bond found in this compound is coordination bond, and it is formed by sharing of lone pair of electron. Okay, representing again through structure to you. Here cyanide ion is donating lone pair of electron to iron. So since iron is accepting the lone pair from cyanide, hence it is known as Lewis acid, and cyanide which is donating electron is known as Lewis base. So these are the basics of coordination compound. Coming further, now coming to the nomenclature portion. Nomenclature, या फिर how to write the names of coordination compounds. Name of cation followed by anion. Okay. if the complex is at cationic site, then name of ligand is written first, followed by central atom, and its oxidation number in square bracket, sorry, curly bracket, simple bracket, I'm sorry. Okay, anionic ligands are written along with suffix IDO after their name. In case of bidentate or in case of polydentate ligands, prefix bis tris tetrakis is used before their name. Okay, so these are the rules for the case when so these are the rules for the case when central atom is at cationic site. If central atom is at anionic site, then scientific name of element central metal and elements are used instead of their common name. With suffix ठीक। वैसे तो ये सारी चीजें बुक पे अवेलेबल है, जितना शॉर्ट हो सकता था मैंने बताने की कोशिश किया। थोड़ा बहुत एग्जांपल देख लेते हैं नोमेनक्लेचर का, जिससे अपने को समझ में आता है। फर्स्ट वन इज K4 FeCN6, शॉर्ट एंड सिंपल, जिसको मैं बार बार यूज कर रहा हूँ। अब इसमें कैटायनिक साइड पे कौन है? K4 यानी काउंटर आयन, एंड एज आई ऑलरेडी सेड कि नेम ऑफ कैटायन फॉलोड बाय नेम ऑफ एनायन, एंड counter ions number doesn't matter while writing the name, we simply write the name only of counter ions followed by name of anion. In anionic site we see that there is compound, complex compound, and inside the complex compound we know that inside the complex compound name of ligand is written first. Then how many ligands are there? 6. So it is written as hexa. It is cyanide, so cyanide. And I told you this IDO suffix is used when the ligand is anionic, and Cn bears minus charge, so here will be written as hexacyanide iron, which is an anionic ligand. Then suffix 8 will be used, and this is scientific name instead of iron. So hexacyanide FeR8 ferrate, followed by its oxidation number in simple bracket. So oxidation number we calculated its oxidation number is +2. Now okay, so it is a common type of question and little bit complicated for students. You will be seeing in cationic side there is complex and anionic side there is also complex, but both having central metal silver only. So in that case we will be writing as per rules. Name of cation first. Cation के side में है complex, तो complex के अंदर सबसे पहले we will be writing the name of ligand. Ligand is amine, which is neutral ligand. How many amines are there? Diamine. So diamine, silver. Now anionic side we will be having, again we will be having a coordination compound. Inside that the name of ligand is written first, so ligand is anionic again, so diamine, silver, dicyanide. Now the central metal is at anionic side, so scientific name will be used, argentate. Oxidation number again x plus 0 plus x plus -2 it will be equals to 0. If you are confused, -2 कहाँ से आया? CnBr charge -1, so overall charge will be -2. NH3 bears 0 charge. NH3 is an organic compound, and each and every organic compound bears 0 charge only. Not an organic compound, covalent compound, and covalent compound does not bear any oxidation number. So how many oxidation number we will be having for silver? +2. Okay, and यहाँ पे 2x, so x is equals to 1 for this silver, 1 for another one. I hope you will be here, you are getting how to write the name of compounds. One more. दो मिनट का टाइम, 10 सेकंड का टाइम आप ट्राई कर सकते हैं, जो बच्चे लाइव देख रहे होंगे. देन विल बी डिस्कसिंग दिस क्वेश्चन. चलिए डिस्कस किया जाए. Zero charge, so it doesn't matter how many NH3 are there. CO3 bears -1 charge and Cl bears -1 charge. So x -2 will be 0 and x will be equal to plus and 2. So the oxidation number of cobalt is +2. So the name of compound is, will be starting with ligand and that too in alphabetical order. So first we will start with pentaamine, then there is carbonate, and it is an anionic ligand. So as we discussed earlier, IDO or O suffix will be written here, pentamine carbonato cobalt 2 chloride. Doesn't matter how, whether it is anionic, cationic, counter ions name written, it's written as it is. I hope it is clear. You will see. Moving to further topics. Isomerism in coordination compound. Isomers are the compound which are having same molecular formula but different structures, whether it is two-dimensional structure or three-dimensional structure. Okay, so now we'll be seeing classification of isomers. It is broadly classified as structural isomer. Broadly classified as structural isomer and stereoisomer. Structural isomers are again classified into following categories. First is coordination isomerism. Second is hydrate or solvate. The third one is, okay, I'll be making place for that. Hydrate or solvate. Then third one is ionization isomerism. Finally, the last one will be linkage. Fine. Okay, so ट्रिक से समझते हैं, इनका नाम ही बताएगा कि इसमें करना क्या है. Stereo is again classified as geometrical isomer and optical isomerism. Symmetrical, it has again classification as cis isomer and trans isomer. Optical shows two types of isomer that are dextro levo. Okay, so these are the broad classification of isomers. In case of coordination compounds, coordination isomerism मैं एग्जांपल दे देता हूँ. एग्जांपल से शायद आप ज़्यादा अच्छे से समझ पाए. इस टाइप का आइसोमेरिज्म में अगर दो कंपाउंड जिनके कोऑर्डिनेशन नंबर सेम है. कोऑर्डिनेशन नंबर मींस नंबर ऑफ लिगेंड्स डायरेक्टली अटैच्ड थ्रू कोऑर्डिनेशन बॉन्ड थ्रू सेंट्रल एटम. हिंदी में ये जो लिगेंड है ना भाई साहब, ये कितने लिगेंड डायरेक्टली आके अटैच हो रहे हैं सेंट्रल एटम में, वही उसका कोऑर्डिनेशन नंबर देता है. यहाँ भी दो लिगेंड, यहाँ भी दो लिगेंड, दैट मींस दे बोथ आर हैविंग कोऑर्डिनेशन नंबर 2. This type of example is shown by this type of isomerism is shown by coordination isomerism. Cu Cl2 Ag Cl. क्या अलग हुआ, क्या अलग हुआ? अलग यहाँ पे ये हुआ कि सेंट्रल मेटल जो थे अपने प्लेसेस को इंटरचेंज कर गए. ओके, यहाँ पे देख सकते हैं, इस पे देख सकते हैं यहाँ पे जो सेंट्रल मेटल था और ये जो सेंट्रल मेटल है, दोनों कोऑर्डिनेशन नंबर 2, दोनों के लिगेंड के ऊपर चार्ज सेम, दोनों अपना प्लेसेस को इंटरचेंज कर गए. टाइप ऑफ जो कोऑर्डिनेशन इसने शो किया वो है कोऑर्डिनेशन आइसोमेरिज्म. आते हैं हाइड्रेट पे. हाइड्रेट में थोड़ा जगह बना लेते हैं, यहाँ बताते हैं हाइड्रेट को. Br3 Cl2 और H2O. इस टाइप के एग्जांपल में नेक्स्ट केस में सेंट्रल मेटल वहीं पे है, NH3 यहीं पे है, एक Br यहाँ से हटा दिया जाए और एक वाटर मॉलिक्यूल को अंदर कर दिया जाए, तो यहाँ पे क्या होगा 4H2O dot Br. So in this kind of isomerism, water molecule interferes the ligand and it changes the position with ligands, and the type of isomerism is known as hydrate or solvate, just because with increase in number of water molecule inside the bracket, it is known as hydrate or solvate isomerism. Then coming back to ionization isomerism.
सर अब खत्म कर नेक्स्ट क्लास में.
हाँ ठीक,
बोल दीजिए.
दो ionization isomerism and okay, ionization and linkage. These two topics are left. We'll be discussing these topics in next class due to lack of time. Thank you to all.